Just check your 6C from your homework here. If you had trouble with it, let's just go over this. Okay, the first function is going to be this function here, x squared minus 1 all to the fourth. The second function is going to be this one, 2 minus 3x. Now, is this outside-inside function right now? There's some of that in the first one here, right? We're going to have to do chain rule when we find the derivative of this. But overall, what you need to notice is that this is a product rule. So we're going to be combining the product rule and the chain rule. Okay? So overall, we start with the product rule. So g prime of x is going to be the derivative of the first times the second. So the derivative of the first is where all of a sudden, right away, we use the chain rule to find that derivative. So this is going to be 4x squared minus 1 to the power of 3 times the derivative of the inside function, which is x squared minus 1. So times 2x. Everyone see that? Yep. The derivative of the first here is this right here. So derivative of the first times the second, 2 minus 3x. Plus, this is product rule, right? We did chain here. Now we're doing product rule. Plus the first, which is the function all by itself, x squared minus 1 to the 4, times the derivative of the second, which is negative 3.
So for the first step, we just kind of substituted the first derivative with the chain rule?
Well, in order to find the derivative of this, you have to do the chain rule. Yeah. So it's the chain rule inside of the larger product rule situation, right? Yep, question?
Where did the 2x come from?
Where did this 2x come from right here? Right? Okay, so remember the chain rule, guys. So when you're taking the derivative of x squared minus 1 to the fourth, okay, x squared minus 1 to the fourth. I'm going to use a different color. X squared minus 1 to the fourth. This is like u to the fourth. So this is your outside function. So that's when you do this part, you do the power rule for this cubed. Right? Now the chain rule says if there's something other than just x, then you have to multiply by that derivative too. Even if it was x, watch this. X to the fourth. Look at guys. We're doing the chain rule on something like this as well. You just didn't realize it. Look at, we're doing 4x cubed. And look at, what's the inside function? It's x. What's the derivative of the inside function? 1. So really, we're doing the chain rule, but we're not even really noticing it because everything so far has just been the derivative of x is 1. So we multiply by 1, it doesn't change anything. But if this is now x, squared minus 1 cubed, well then I have to address this. I have to multiply by that derivative. Got it? Okay, so that's the first line, first step there. And what you're going to want to do here is you're going to want to simplify as much as possible. So what can we do here? Let us make this black. So 2x times this times 4. We could probably do that. That's 8x times 2 is 16x. 8x times negative 3 would be minus 24x, I suppose. Right? Times x squared minus 1, all cubed.
Isn't it 24x squared?
Could be. 8x, and yeah, that's squared, thank you. And then minus 3 times this, x squared minus 1 to the fourth. So can we factor anything out of here? We can, actually. We have actually 3 of these in both, don't we? So if you were factoring, you would want to take that big factor out, x squared minus 1 cubed. And what's left over? Well, this right here, and if you wanted to leave that as factored, so I multiplied that in, that's fine. But you actually could take an 8x out here, right? So that's 8x times 2 minus 3x. And then minus x squared minus 1. 3x squared minus 1. Everyone seeing that? So I took out 3 of these from both of these. Okay, so there's one term. Here's the other big term. I took a common factor of x squared minus 1 to the power of 3 out. Put it right there. Then what's left over? These are all gone then. So I factored this, took an 8x out. So I factored this expression.
Is that like an essential step?
What's that?
Is that like a necessary step?
Well, see, look. Well, in this, it turns out that you can combine some like terms here. So if there is a situation where you can combine some like terms, you don't have to do this factoring from this, because you see how there is actually a squared term and another squared term here. So you want to combine like terms. So if you look at something like this, you say, hey, you know what? This factor, actually, I'm going to expand this out because I can simplify that some more. So normally you would want to factor and leave it there, but like I say, if there's like terms that show up. So this is now going to be, what do we say? I guess that's 16x minus 24x squared minus 3x squared plus 3. So now, yeah, see, there's some like you can gather. So in that case, you wouldn't need to factor this. So x squared minus 1 cubed. What can we gather? Those, right? It's negative 27x squared plus 16x plus 3. And if you can factor this out, if you can factor this, then go ahead, but it doesn't appear that you can. Okay, so this is there some chanting back there? I don't think you said loud enough to be. Well, I knew I'd hear, but the microphone can't hear you. You guys want to? Okay, shout it out. Ready?
I say Mister, you say MathWell, Mister.
MathWell.
Mister.
MathWell, where are you guys at?
Okay, that's really good. Thank you for the enthusiasm, both of you. Extra marks. Okay, just for that, I will actually mention you on this video.
Oh, yeah.
Joy and Jaya for doing the chant. Good work. Nobody else. Nobody else.
Is that bonus marks or what?
Well, don't get crazy with bonus marks. I'm not going to give you bonus marks.